Assalamu alaikum dear aimers, hope so you all are doing well. Today the topic of our discussion is some of the most important points from dark reactions. Many students understand the topic of dark reactions, but when it comes to the questions they are damn confused. So I'll try to clear all of your confusions in this lecture. So let's start the lecture. So the first point is, or the first question is, that the number of carbon dioxide molecules required to start Kelvin cycle. So this is a very important MCQs. We saw in the Kelvin cycle that we use 3 molecules of carbon dioxide to make 3 carbon carbohydrate, which was triose. Now, it doesn't mean at all that 3 molecules of carbon dioxide will be required to make to start the Kelvin cycle. We use 3 molecules of carbon dioxide to make a 3 carbon carbohydrate. Otherwise, 1 molecule of carbon dioxide is required to start Kelvin cycle, which will make a 1 carbon compound. And then another Kelvin cycle, then 2 carbon compound, and then another Kelvin cycle, then 3 carbon compound. So do remember that 1 molecule of carbon dioxide is required to start Kelvin cycle. When there will be 3 molecules of carbon dioxide, it means that 3 Kelvin cycles have been completed to make a 3 carbon compound, which is triose. Do remember that all the carbon molecules or all the number of carbon atoms in a carbohydrate is obtained from a carbon. If triose has 3 carbon, it means that we had 3 carbon dioxide in Kelvin cycle. If we form a hexose has 6 carbons, so it means that we had 6 carbon dioxide molecules in a Kelvin cycle. Okay. The next point is, what is the ratio of carbon dioxide, NADPH and ATP in a Kelvin cycle? So we saw that this is the ratio. So we saw in the Kelvin cycle that we use 3 carbon dioxide, 6 NADPH and 9 ATP. I hope that you all remember this topic. So this was the ratio used in the Kelvin cycle for triose. So this is for 3 carbon carbohydrate. We are talking about 1 Kelvin cycle. 1 Kelvin cycle means 1 carbon dioxide. So if we simplify this equation, if we simplify this ratio over here, 3:6:9, then what will be the answer? We will simplify it with 3. So 3 1s are 3, 3 2s are 6 and 3 3s are 9. So do remember the sequence that 1:2:3 is for carbon dioxide is on first number, second number is on NADPH and third number is on ATP. So do remember, if we will have a 1 molecule of carbon dioxide, then NADPH will be double of carbon dioxide molecules and ATP will be triple of carbon dioxide molecules. Like in Kelvin cycle for making triose, we had 3 molecules of carbon dioxide, so NADPH will be double of it. So these are 6 NADPH and ATP will be triple of it. So 3 2s are 6 and 3 3s are 9. So for NADPH, you will multiply the number of carbon atoms with 2. And for ATP molecules, for the calculation of ATP molecules, you will multiply the number of carbon atoms of a carbohydrate or of a carbon dioxide, because both are same, with 3. Got it? We will do more questions from this topic, then you will completely understand it, how you have to find carbon dioxide, NADPH and NADPH ratio. So look at the next question. The next question is number of ATP molecules to form triose. Firstly, revise what was the ratio between carbon and ATP. We saw in the Kelvin cycle that 3 carbon dioxide or 3 carbon carbohydrate triose was there and 9 ATP were required for it, and there were 3 Kelvin cycles completed to form this triose. Now in the last slide, we looked at the ratio between carbon and ATP. I told you that the number of ATP molecules will be triple of number of carbon dioxide molecules. Like for 1 carbon atom, there will be requirement of 3 ATP. So 1 carbon dioxide makes 3 ATP, 2 carbon dioxide will make 6 ATP. You have to multiply it with 3 because it's 1:3. So 2 3s are 6, and for 3 carbon compound triose, the 3 carbon dioxide molecules will be used, and the ratio is 1:3. So you have to multiply 3 with 3. So 3 3s are 9. So in triose, there are 3 carbon. So how you have to solve this question? I'm telling you in a simple way. In triose, there are 3 carbons. So 3 carbon dioxide will be required. And you remember that the ratio of carbon and ATP for a Kelvin cycle is 1:3. For 1 carbon, there will be requirement of 3 ATP. So what you will simply do, there are 3 carbons, so you will multiply 3 carbon with 3. So 3 3s are 9 ATP. Next question is number of ATP to form 1 glucose. So in glucose, how many carbons are there? 6 carbons are there. ATP required will be triple of it. So you will just multiply 6 multiply 3. So 6 3s are 18. Now number of ATP to form 1 sucrose. In sucrose, there are 12 carbons. So you will simply multiply 12 with 3 because 3 ATP are required for 1 carbon. So 36 ATP will be required for 12 carbons. Got it? So if you have to find carbon and ATP ratio, simply multiply the number of carbon atoms with 3. You will find the number of ATP molecules in this way. Now the next question over here is related to the NADPH. Now number of NADPH required to make triose. We saw in the last slide the 6 NADPH were required for 3 carbon triose. Okay, and we also saw that the ratio of carbon NADPH was 1:2. So if there is 1 carbon dioxide, then the double will be NADPH. Okay, so if there are 2 carbon dioxide, then the double will be NADPH will be 4 NADPH. So in case of ATP, you have to multiply the number of carbon atoms with 3. While in case of NADPH, you have to multiply the number of carbon atoms with 2. Got it? So 3 carbons were required, 3 carbons were there, 6 NADPH were required in Kelvin cycle. So for 1 carbon, 2 NADPH will be required, because you will divide 3 by 6. So it will become 2. Sorry, 6 by 3. So it will become 2. Now, number of NADPH required to make 1 glucose. So in glucose, how many carbon atoms are there? 6 carbon atoms are there. NADPH will be double of it, because you remember the ratio 1:2:3. So glucose will be 6 multiplied by 2. So for 6 carbon atoms, there will be 12 NADPH. And number of NADPH required to make sucrose. In sucrose, there are 12 carbon atoms. NADPH are always double of carbon atoms. So you will multiply 12 with 2. So there will be 24 NADPH. Got it? In case of ATP, multiply the number of carbon atoms with 3, because ratio of carbon and ATP is 1:3. While in case of NADPH, multiply the number of carbon atoms with 2, because the ratio between carbon and NADPH is 1:2. So here is the chart or a summary I have designed for you, that number of Kelvin cycles required to make 1 hexose. So I told you that Kelvin cycle will start with 1 carbon dioxide to make 1 carbon carbohydrate. Okay, 1 carbon molecule, you can say carbohydrate, because carbohydrate starts from 3 carbons. So 1 carbon compound will be formed, then 2 carbon dioxide will make 2 carbon compound, 3 carbon dioxide will make 3 carbon carbohydrate. Okay, so as we have to understand the formation of carbohydrate, so in the last lectures we followed 3 carbon dioxide molecules, because I told you that number of carbon dioxide molecules, number of carbon atoms in carbon dioxide and in carbohydrate, they will be same, because all the carbons in carbohydrate comes from carbon dioxide. I told you in the very first lecture, general concept of light and dark reactions. So 4 carbon dioxide will give 4 carbons, 5 carbon dioxide will make 5 carbon carbohydrate, and 6 carbon dioxide will make 6 carbon carbohydrate. Got it? So this was from today's lecture. And if you have got the lecture, have a big smile on your face. These all questions are really important. Just practice it once or twice. You will get all the concept. So be happy, make others happy. See you in the next lecture. Allah Hafiz.